Hello everyone, this is the first lesson for antiderivatives. You will recall that previously we had been talking about the derivative of a function in chapters 23 and 24, so that if you had a function like y equals to x cubed, you can take the derivative of that function and your result will be 3x squared if we use our power rule that we had discussed previously. But now we are going to reverse what we did before, which is what antiderivatives would mean. So for example, if your antiderivative is dy dx equals to 3x squared, that's your derivative. The antiderivative is going back to y, which was the original function that you had to take derivative of to get 3x squared. And that symbol is this s-like symbol that we had here. So there's the antiderivative of 3x squared dx, which means that you are taking antiderivative with respect to x. Your result will be x cubed plus c, where c is some constant, a real number. Now, of course, what this implies is that if you take derivative of x cubed plus c, you will get exactly 3x squared back. And the c there implies that it could be any real number. So I have a few examples for you, like x cubed plus 10, x cubed minus 7. If you take the derivative of these functions, you will get 3x squared, which is why you would have the constant c when you talk about the antiderivative. Later on, maybe we'll see how to find the constant c, but generally speaking, when you take the antiderivative of a function, you always have this constant c in your result. Some of the basic rules that we'll use for antiderivatives are as follows. We are going to assume that we have a function u, it's a function of x, and you have a constant c, which is a real number. The first rule is that if you take the antiderivative of a constant k, it will always be k times u, where u is a function of x, plus, of course, the constant c, constant of integration. And if you are taking the antiderivative of a sum, basically speaking, all you have to do is just take the antiderivative of each piece in the sum plus the constant of integration c. And finally, you have the reverse of the power rule that we had used before. If you have something to the power of n, the antiderivative is to just add 1 to that exponent and divide by the new exponent, n plus 1, then plus c, which is a constant of integration. So we're going to see this in some of these examples that we're going to do right now. So for instance, let's take the antiderivative or integrate 6x. So antiderivative of 6x dx. The rules we're going to use both the power rule and the constant, the antiderivative of a constant. Of course, what will happen with that is that if you take the antiderivative, the 6, which is a constant, can just come out. It's a product with 6 and x. So you can pull that out and you have 6 times the antiderivative of x dx. The exponent for x is 1, so it looks like your power rule law that I wrote down here. So that if you take the antiderivative of that, you have x to the power 2 divided by 2. And you are multiplying that by 6, plus your constant of integration to give you a final result of 3x squared plus c. And to check that you are right, if we take the derivative of 3x squared plus c, we will get exactly 6x back. The next example, we're taking the antiderivative, but we are integrating 5x cubed minus 6x squared plus 1. And that will proceed as follows. We are going to need to use the product relationship, the sum relationship I showed you earlier on. The formula we're using is this one, together with the power rule, of course. So if you take the antiderivative of that, you can take the antiderivative of each piece in the sum, and then use your power law to take the derivative of x cubed, x squared, and dx. That would give you 5 times x to the power 4 divided by 4 minus 6x cubed divided by 3 plus x plus the constant of integration c, which will give you a final result, if you simplify, of 5x to the power 4 divided by 4 minus 2x cubed plus x plus c. Sometimes you have scenarios where you will have to rewrite the function first before you can take the antiderivative so that it will fit the power relationship. So for this example we have here, we're going to apply the sum relationship as well as the power relationship. But first of all, we have to rewrite it. Square root of r is r to the power half, and 1 over r cubed is r to the power negative 3. So now if we rewrite the integrand the way we're written right now, we can now use our antiderivative of a sum. We'll distribute over each of the pieces in there, and then take the antiderivative of r to the power half and r to the power negative 3. For each one, we are going to have to use the power relationship as shown here, which will give us so if you take the exponent half, all you have to do is just add 1 to it and divide by the new exponent, which is half plus 1. Similarly, for r to the power negative 3, we'll add 1 to negative 3 and divide by the new exponent, negative 3 plus 1, plus the constant of integration, c, which will give us a final result, or something, it will give us 2/3 times r to the power 3 halves plus half times r to the power negative half plus c. And finally, we'll have a result of 2/3 times r to the power 3 halves plus 1 over 2r squared plus c. Okay, so I hope that's clear. What we will do now is I have a few things here for you to try. I have like 3 examples here. So you try these, and what you should do is just pause the video now, and then try your hands on these 3 examples. When you finish, you can continue the video to see what I have done. Okay, so please pause the video now. Alright, so hopefully you have finished those examples now. So let me share with you what I did. So for the first one, it's very straightforward, that one, because you just have 6x squared minus 5 dx. So all you have to do is just take the antiderivative of each one of them, and when you combine them, you will just get the final result of 2x cubed minus 5x plus c. That one is fairly straightforward. This one, you would have to rewrite the denominator 4 over root x as 4x to the power negative half dx, and then once you do that, you will just have 4 times x to the power negative half, the antiderivative dx. Then change the exponent. If you add 1 to negative half, you will get 1/2, and you're dividing the result by 1/2 plus c, which will give you a final result of 8x to the power half plus c, which is just 8 root x plus the constant of integration, c. And finally, this last one, again, you would have to rewrite this one. First of all, before you take the antiderivative, using your exponent rules, you have 3r times r to the power half minus 5r squared, which will give you the antiderivative of 3r to the power 3 halves minus 5r squared dr. So now you can use your sum relationship to distribute the antiderivative sign over each of your pieces in there. And then you take the antiderivative of 3r to the power 3 over 2. If you add 1 to 3 halves, you get 5 halves, and you're dividing by 5 halves minus 5r cubed divided by 3, and that will give you a final result of 6 over 5 r to the power 5 halves minus 5/3 times r to the power 3 plus c. So that's how to do basic integration. This one is still very basic. We're going to see some, I'm going to show you other ones where you have to do integration by substitution, and I'll show you how to be doing that one. That will be our next video that I'm going to put up.